All right. Hello and welcome to another episode of Containers from the Couch. Today, I'm joined by AWS experts, and we're going to be diving into VPC Lattice and Amazon EKS. By the way, guys, I think we were live that first time I hit go live. So excuse us for a bit of those technical difficulties, but we're excited to get into it today. As you know, in Containers from the Couch, we like to have very demo-focused episodes. So Eve, I'm going to start with you. You're our demo extraordinaire today. Tell us a little bit about yourself and what you do at AWS, and give us a peek into what you're planning to demo for us today.
Sure. So yeah, I'm Eve, based out of Munich in Germany, and I'm a container specialist just as you saw. And but I have a long networking background. Actually, I spent the last 10 years doing container networking from the very beginnings. And so yeah, I'm in between this container world and the networking world. Yeah, and today I'm going to show you how we can do blue-green cross-cluster patterns with VPC Lattice, and also show you the latest feature that we added, which is the support for TCP resources. So we'll access RDS and Vitess databases through VPC Lattice from a Kubernetes cluster. So this is what we'll look at later.
Excellent. Really excited to see these demos, and I've seen a quick peek at them. Really excited to see how these play out. Satish, going to go to you next. Tell us a little bit about what you do at AWS, and I'll start with an opening question for you as well. What is the Gateway API? Of course, in the context of Kubernetes, and why is it important to EKS users, customers everywhere?
Sure, Sai. Yeah, thanks for having us. And good afternoon, good morning, good evening, everyone. So I look after go-to-market for application networking in general at AWS, and particularly VPC Lattice. So, Sai, to your question, why is Gateway API important, right? So the current Ingress APIs that most customers deploy with load balancers at L4 and L7, they've had some limitations, like having to require custom annotations when they had to do advanced routing features like weighted routing for blue-green canaries, etc., or even like adding like a role-based control, like who does what, right? So the the deployment from the platform team versus what do the developers do? They were stepping over each other in lots of ways. And then some other things like cross namespace support, as in multi-cluster support, being able to have that very simply, easily defined. And also multi-protocol, like, Ingress APIs typically supported just HTTP, and you had to do lots of custom annotations to do others. So Gateway API now extends it to gRPC, TCP route, TLS route, and gives you a very specific, easy way to sort of do that. So that's the evolution of the Ingress APIs, and getting towards easier way to sort of have a role-based definition, and also expressiveness in terms of being able to have different protocols expressed, and then what you want to do for each of those services, the path-based routing in not just was limited in Ingress to path-based routing, versus here now you have additional controls like header-based routing, etc. So all to say, short answer, it sort of gives you a better flexibility, better role-based access control, and also gives you multi-protocol support for Ingress, both north-south and east-west.
Yeah, I think you hit the nail on the head here, Satish. I've been working with EKS customers, Kubernetes users for a long time, and I think the two things that they really want to see are, flexibility, the ability to do very specific custom things. In addition, doing it in a way that ideally reduces operational overhead, not increases it. So I think you kind of hit on both of those things. And I think the Gateway API being this open source initiative, it's like this evolution of Ingress and Kubernetes, right? Is helping hit those two things. Of course, there's the third thing the customers care about, cost. But that's all published in the docs as well. Today, we're going to be focusing on the flexibility and the extensibility, as well as how it plays into Kubernetes operators, helping reduce their overall operational overhead. So we talked about this being the evolution of Ingress. And so Gateway API introducing a new type of resource into Kubernetes, making it easier for operators to define routes to their application, HTTP routes even. And so that's a little bit of a hint into what we're going to be seeing next. Ryan is going to show us a little bit about how this stuff works. Ryan, tell us a little bit about who you are, what you do at AWS, and tell us how Gateway API is an evolution of Ingress.
Sure. So my name is Ryan. I'm one of the software engineers on VPC Lattice. I had the pleasure of launching it a couple of years ago now. So exciting things along the way, but more recently I've been focused on leading some of the our Gateway API efforts. These two folks here. So like Satish mentioned, the Gateway API is kind of aiming to take a step back and look at some of the inefficiencies maybe of Ingress and service, and come up with a new set of APIs or new method of kind of getting everything from both of those in kind of an easier package. If you don't mind bringing up the slides there, it might be easier for me to show here. Awesome. So you can see here, when customers typically work with Kubernetes objects in the past, this is kind of what a typical definition would look like if you were using a service, using L4 connectivity with the service API, and then kind of how that would look if you were using layer 7 with the Ingress API. So you can see there's some similarities there, but there are some obvious differences as well. The object on the right is kind of what the Gateway API offers. So you can see that it does support both layer 7 and layer 4. So that's HTTP, gRPC, TLS, TCP, UDP. So you can see it is quite powerful in its simplicity there. Yves will get into some how we can actually use these objects, but the goal is to kind of cut down on maybe some of the additional annotations or additional extensions that were required on the previous APIs and kind of bring them forward into this Gateway API. So like I said, I'm kind of leading the charge on Lattice side, I should say, for this Gateway API. So we own a public GitHub with the API controller. It's written primarily in Go. Maybe I can get into a bit about how that works later. But yeah, kind of excited to show it off here.
Awesome. And Ryan is being modest here. He's one of our, software engineers, and he's been building out support for the Gateway API and in AWS, helping integrate it with EKS. So excited to have you on here, Ryan, of course, with Satish and Yves as well, to really go through the solution and see how it all works together. Okay, so guys, open-ended question here a little bit. So we've seen that, this new approach with the Gateway API, this HTTP route, allowing us to handle L4 and layer 7 type routing with kind of a simpler spec, a simpler resource, right? So Satish, or really any of you, can you talk a little bit about why the community decided to introduce the Gateway API? What were the challenges that customers were facing with the old way of doing things?
Sure. Let me start, and if you can add. One of the key limitations before was around having to do these custom annotations, right? For beyond just HTTP route. How do you define layer 4? How do you specify a gRPC route within in Ingress API, for example? So the multi-protocol support was one, and then in terms of role-based control that I was mentioning before, like what role does the platform team play in the manifest versus what does the developer have control on? How do you set up your blue-green deployments, et cetera? So those are some of the reasons why the community has decided to sort of move towards a more standardized approach for Ingress, and that's where the Gateway API for both north, south, and east, west. Yves?
Yeah, and I think that if you would ask a couple of folks that were very early on in the community what they would do different, then they would name the service as being one of those objects that they would design differently today, because it's very overloaded. So it is used as a service discovery construct. It is used as a load balancing construct. And it is used just for too many things. It's also used as like a means of collecting pod IPs and endpoints. And then implementers like us had to put tons of annotations onto these objects to make it work in our environment. So if you look at the service definition here, no one would have such a service definition with load balancer. You would have at least 5 or 6 additional annotations that control how things are done on an AWS NLB or CLB. On the other side, with the gateway API, you have the gateway objects. There is unfortunately no example here on what that looks like, but the gateway object is basically where the load balancing or the ingress into the cluster is applied, while the routes is how it is applied. And so it's a much cleaner separation. You have the gateway defining the listeners, etc., and then the other defining on how to get or what you do in terms of routing into the cluster, eliminating most of the annotations that are used in those ingress and service type load balancer implementations.
Got it. That makes a lot of sense. And, I'm thinking back to the days of Istio, Service Mesh, and betas, like, years ago, maybe 5 years ago now. And I remember that they themselves had decided, that Kubernetes Ingress doesn't do all the things we needed to do. Yeah. We're going to make our own gateway. And I think that kind of mimics some of the challenges you were explaining for, Kubernetes is all about extensibility, and the community realized that that current or legacy implementation, I guess you could say, with services and Ingress, didn't quite achieve what every use case wanted or needed, and so the Gateway API was introduced. And so Gateway API being a Kubernetes API, an open source initiative and project, and something it's like an add-on for Kubernetes clusters, but can also consider it as a built-in capability, depending on if you have the support for it in your cloud provider and that kind of thing. I've got to ask, how does this relate to VPC Lattice, which is in the title of our episode today?
Yeah, we're seeing a lot of customers, evolve as they're deployed single large clusters and sort of moving to multiple large clusters, like sharding per account to increase the developer velocity, for example, right? And so they're having to deploy, multiple Ingress controllers with Ingress APIs. How do they talk to each other? And having the same service potentially deployed across multiple namespaces and across multiple VPCs on AWS. That's sort of where we built Lattice with Kubernetes as one compute type. Lattice also supports our other container orchestration, ECS, and also serverless functions, Lambda, and if you're running on EC2. Specifically for EKS, we've had a lot of customers ask us about, hey, how do you help us support multi-clusters across multiple VPCs? That was one driving factor. The second one was about, give us a way to sort of help us do a very Kubernetes native way. This is where Gateway API shines in terms of being able to be very portable. You define your deployment spec with the details depending on your protocol support. The multi-protocol support is really helpful. And then being able to say, I just want all of our automation to be through my Kubernetes manifest. So go and create. So that's why we built the controller and open source it, and it's available. We'll share the links. And there we've added more automation in there, and some of the pieces still require some CRDs to go like do target group policy automations, etc. But the goal here was to sort of build a Kubernetes native way, being able to say, give us multi-cluster support with all the routing service definitions already built in to the controller, and not have to go outside and do something else, versus it's all built in through the Kubernetes APIs.
Got it. That makes a lot of sense. And I know for our viewers that are watching, I know you're ready to see some of this in action, see how it works. Very quickly, I think one of the things that people need more advanced network connectivity for are a number of use cases. Maybe they want to do advanced traffic routing, right? Like canary deployments or A/B testing. Maybe they want to do blue-green deployments where they have different versions of the application, different clusters, or maybe they're upgrading from cluster blue to cluster green. Whatever the use case might be, network connectivity within a cluster, great, easy. Kubernetes handles it. Now, when you're talking about multiple clusters or different accounts, different regions, that's where it starts to get tricky. Things like failover, circuit breaking, all of these really advanced topics. So let's start, Eve, with seeing exactly how this works and how some of these more advanced networking connectivity use cases can be handled with VPC Lattice.
Sure, let's go.
Let's do it.
Okay, so what I want to quickly show you here is, first of all, the blue-green clusters setup and the demo for it. So why would somebody want to have blue-green clusters? In a lot of cases, this is, or not a lot of cases, there are use cases where you want to have immutable clusters. So you don't want to ever change your Kubernetes version in your cluster. Actually, EKS is great at upgrading your clusters, so that might not be the right thing for you to do, but there are customers that want to have immutable clusters, and in this case, you want to move the application from one cluster to the other, and you want to test first if things work, and so you do that in a blue-green pattern. Other use cases would be if you have disruptive changes like changing the CNI or going to IPv6-based clusters. So there are a lot of cases where you want to really move your application between clusters. So VPC Lattice helps us doing that because the VPC Lattice service is able to target different clusters in its target groups. So what I will show you now is we have a blue cluster. And in that blue cluster, we have the blue version of our web service. And in the blue cluster, we are able to export the service through a service export object, which is creating a target group for us on the VPC Lattice side. And that service export, we can import on the green cluster. And in this case, the green cluster will be the owner of the HTTP route, and the HTTP route is actually the owner of that web service. But to start with, we actually have the blue cluster owning the HTTP service, and we have to migrate it. But that's a part of the prerequisites that I already did, so that we don't lose too much time on that. So the blue cluster already has the service export, and what you need to do then, if you move the ownership over of that Lattice service to the green cluster, is you need to change the manage by tag on either the console or through some automation through the CLI or the API, so that this new green cluster is now owning the service object. And that's, from a data path perspective, non-disruptive change. So the traffic will just keep going. It's just an ownership change to the green cluster. And then on the green cluster, you can create an HTTP route that is importing the service that was exported before, the service that was exported before, and we will see that now in the demo.
So,
before I go to the demo,
really,
any questions?
Yeah, sorry, really quickly. So essentially what we're trying to do is, we've got a service in blue cluster that we're exporting, kind of like the representation of, and in cluster B, we're essentially importing it. And so now any other service in cluster B can just route directly to that service running in the blue cluster, using basic Kubernetes DNS routing and all of that. They don't have to set up any complicated API gateway or anything. Just boom, give me that service running in a different cluster so I can hit it as I would any other service in the green cluster.
Yeah, and I mean, the main benefit is also you don't have to rely on DNS. Other solutions involve basically DNS with weights, so that you respond with 20% on the blue cluster and 80% on the green cluster. However, you have all sorts of funky stuff happening with DNS caches. So it might not work that well for established sessions, while here we have a real load balancer that is doing the work for us, draining connections from one target group to the other, and doing a better load balancing than a DNS-based solution would do.
Do both of these clusters have to be in the same VPC?
No, they can be in different VPCs. They can even be in different, they can be in different VPCs. In this case, they're actually in the same VPC, but that's just the detail.
Does it take advantage of like the performance in those cases? Like if it's within the same VPC, is that like lower latency, and like is it going out to the public internet to come back in, or is it all happening?
No,
privately?
not at all. It's all within VPC Lattice, and there is no difference of single VPC versus different VPCs. At least if Ryan doesn't say differently. He developed it, so.
Yeah, no, it's not going over public internet. It's like you said, it's all through internal through Lattice.
Yeah, and we've tested the latency, same across, same VPC or across VPCs, across accounts. That all is the same latency. That's how the data plane works today. Yeah,
that's a good point. Across account, I think is something that it's important as well if customers do want to go that route.
Yeah. So let's quickly look. We have our EKS Lattice VPC. This is where those two clusters are in. I failed naming them blue and green, but at least on the CLI, you will see blue and green being referenced. Those are auto mode clusters, actually. So all the pods running in there are running with auto mode. So the nodes would come and go and be automatically upgraded. And VPC Lattice just works fine with auto mode clusters. And the controller is then running on one of these auto mode nodes. So let's go to the console here. And here we see we are on the blue cluster. And we have the web service running on that blue cluster. We see that we have two endpoints. Those are actually the pod IPs. And then we don't have an HTTP route because I already deleted it from this cluster. But what we have is a service export. And that service export is simply targeting this web service and is of the federation type Amazon VPC Lattice. And what that does on the VPC Lattice side, let me go to that one, is to create a target group. And that target group has specific tags, which is the service export tag, the service name web service, and who is the owner. And in this case, I already changed the ownership. Actually, this is not changed. Sorry, the ownership is changed on the service. So basically, the controller is looking when you do a service import for service exported target groups. So this is why we have this federation here, because VPC Lattice is our method of federation between Kubernetes clusters.
So quick question here. So when doing the service export, I think the interesting thing, you're showing all the resources getting created in the console in AWS, the target groups and all that, but the operator doesn't really have to know about that, right? They just have to create these resources in Kubernetes, and how do those resources get transformed into AWS resources? Is that where the controller comes in?
I might be able to speak to that a little bit. So yeah, essentially the controller is taking the Kubernetes representation of resources and translating them to Lattice resources behind the scenes. It's part of a reconciliation process. But like you said, this is all invisible to the operator. But if you want to kind of dig into how it works or visualize it, the console is a great way to kind of see what's going on there.
Got it. Yeah, it helps. You can see what's going on behind the scenes, but once you know it works, just restrict your operations to Kubernetes and everything just takes care of itself in the back end. Cool.
So that's now the green cluster, and we have our service import here. And that's a very easy object. It's basically just referencing to that web service. There are annotations with which you can also say import it from only this specific cluster. So restricting what you want to import if you have conflicting names. Now we have on the green cluster an HTTP route. Oh, I don't want T too much. And this is the HTTP route for the web service. And if we look at it right now, we have two backend references. One is the service imported web service. So that's the blue one. And right now we have a weight of 100. So we're sending everything to the blue one. And then we have the internal service, which is like this, the same named service that is running on the green cluster, and it has a weight of 0. And so if I access now this host name, then what responds to me is the blue cluster, or the blue pods. Now, I have a shorter version of that call, and you see it will only respond with blue. And this is what I use with a little tool that I wrote here, which is bursting like 50 requests per second and checks what is the response. And in this case, the response is always blue because we haven't changed the weights yet. Okay. So let me quickly go to the console to the service and show you here what the routing looks like on the listener. Again, this is not something that you would do if you're only concerned with the Kubernetes side. It's something that you can just look at, like how is it implemented in this case. And you see we have 0% going to this target group, which is the green target group, and 100% going to the blue target group. So this is how VPC Lattice does the distribution here now. Okay, so now what we can do is we can play with the weights. So here I'll just apply a new manifest, and that manifest sends 70% to the blue and 30% to the green service. So we'll apply it here, press refresh here.
Eve, real quick, you got to tell us how you're doing that. There's no way you're typing that quickly, right?
I'm not typing that quickly. So if you want to look it up, there is a great a GitHub repo, which is called demo-magic. And it's simply a shell script that does the typing for you. So you import that shell script, and then you can have commands saying type this, and it looks like typing.
Okay, that's awesome. I feel like if I was you, I might just say, no, I've been doing this so long. I'm a hacker typer. That's cool. Sorry to distract. Oh, what you can
Sure. No, actually, big shout out to demo-magic. It's a great project, and it's so simple. Right.
Very cool.
So yeah, you see, we applied the weights now, and now we see that blue gets around 70%, while green gets 30. I don't expect you to count those hashes, but it should be about that, right?
Is that kind of like a load balancer you're running behind this, like a load test you're running behind the scenes? And you got to tell us, what are these cool tools? What is this?
Oh no, that's a self-made Python script that is actually using threaded calls with request library. So I'm basically starting 50 threads that all send a Python, use the request library to send the call to Lattice here.
Got it.
And then I'm just simply counting the number of responses and building this character graphic. So happy to share with that shell script, that Python script. It's actually pretty easy.
No, that's very cool. And last question here. So right now the split is just, like a dumb 30/70. It's not looking at user headers or anything like that. It's just straight up request comes in and it chooses to split between the two, right?
Yes, I mean, here in the rules, you could have much more complex rules, looking at URLs, looking at host headers, etc. And that would then be applied as rules on the VPC Lattice side.
Got it.
That's the advantage of the Gateway API spec again. So these are standard definitions in the API itself that all controllers have to implement. So this gives you that portability.
Got it. So realistically, I mean, you could use this type of configuration on a different Kubernetes cluster that maybe isn't using VPC Lattice. Maybe it's like self-managed and it's like a self-managed controller. So it's similar spec, maybe the exact same spec, so reusable in that regard, which I love, right? Because we're in Kubernetes world right now. We don't want to build a one-off solution. We want to build something that works with the community. I like that.
So it just changed from to 100% green, and you saw it happening. Now all come from green. And this is then the point where you just let it run 100% on green for a couple of days. And if you're happy with it, you just remove that service import here from the HTTP route, and you are all on green and can decommission your blue cluster.
Okay, so we've basically seen how, when moving from a blue to green cluster, you can really have the green cluster still referencing a service on the original blue cluster until you're ready to decommission. So you do a more gradual traffic shift, which is great because there are some very important components, right, that customers can't afford to let go down. So they try to bring it up in a different cluster so they can gradually shift over traffic. That's really cool. I think that's a really common use case that we see in the world of Kubernetes, especially when you consider how challenging it can be to do upgrades sometimes as well, Kubernetes version upgrades. So definitely something that I think offers folks a lot of value. Now, Eve, earlier you mentioned there's new support in VPC Lattice as well. What is that? You mentioned, I think it was TCP related. Can you show us a little bit about how that works?
Yeah, absolutely. We'll show that next. Just one thing that I wanted to add. So this is cross-cluster, but obviously inside of a cluster, we can also do the same with weights and target different services inside of one cluster, right? So what I'm showing here is actually the most complex version of multi-cluster support of it.
Oh, makes sense.
Yeah. Okay, so let's talk about TCP support then. Or Ryan, Satish, any other additions to?
Sorry, no, I'm good on my end. I think you're doing a great job.
Well, actually, we had a quick question in the chat.
Okay.
I think probably for Ryan here. Here, Ryan, I'll make sure your face is not blocked. Sorry, I clicked the wrong comment. But is the controller available as an add-on in the EKS console?
It is not currently available as an add-on, although we are exploring options on how to get some tighter integration there in the future.
Okay, got it. So at the moment, and how I've done it in the past, you guys have a really streamlined Helm-based installation, right? So just run the Helm command, good to go.
Yeah, and I think if it's not shared already, we can share out the GitHub repo there. There's I recently redid the setup and kind of onboarding both for a typical user or a developer of the controller. So you should be able to get up to speed pretty quickly.
Cool. I'll share a link to that in the chat here in a moment. And Eve, back to you. Let's see the layer 4 service demo.
Absolutely. So what our customers have asked us is, hey, this is great. VPC Lattice solves a lot of great use cases with HTTP services. What we also haven't seen is the ability of using ZigBee4 signing for authentication authorization, which is also a very cool thing to do. But customers still wanted a solution that would also allow them to connect to any TCP-based resources, like databases and like any TCP-based service. And to enable that, we now released the resources support in VPC Lattice. And the way this works is we have a new construct, which is called Resource Gateway. And the Resource Gateway you deploy in a VPC, can be another account, can be in the same account. And that Resource Gateway is your entry point to the resources that you want to share. And then you configure what is called a resource config. And that resource config can either target a RDS database by means of an ARN, or it can target anything that you can resolve through public DNS. It can actually also target static IP addresses. So here on the right side, we have a resource provider, like in this case, a databases account, which is then sharing these resource configurations with the actual consumer, which would be my front end and middleware account here. And then once they are shared through RAM, Resource and Access Manager, then they can be associated to the VPC Lattice service network by means of a resource associations. And that enables us to use VPC Lattice not only for those HTTP services, but also for services inside of that VPC to access those databases or other things through TCP directly instead of just HTTP services. So let's just jump into the quick demo showing you what this looks like. So here we have an RDS database, and this light greenish color here is my provider account, so my resource provider account. And that database has a specific ARN down here, AWS or Amazon resource name. And that ARN we configure in a resource configuration. So this is my RDS ARN resource configuration. And that configuration is then shared via RAM to the consumer account. So here, if we look at the consumer account that we looked at all the time here, we see that those resource configuration arrived on our side. Couple of things are grayed out because they're only the provider's ability to change things. But we now have a service network association here. So I already associated that resource configuration for the RDS database to the Lattice service network. And now what we can do with that is we can look at those associations, and then we have specific host names that are generated by VPC Lattice here. And those host names would resolve to the DNS name or the RDS IP address. Actually, here I'm using the more difficult way to map a private hosted zone name to that longer FQDN, but especially for RDS databases, we have the ability to also share the DNS names that are used, that are auto-generated by RDS itself, into the consumer account, also to make things easier. But here, I'm mapping it manually. So going back to Kubernetes, because we want to know what this means for a Kubernetes user, here we have a deployment, which is my card service. And if we look at the card service, then it wants to connect to a MySQL host, which RDS int example.com. And this is the private hosted zone entry that we just saw that maps to VPC Lattice. So here I have a backend service. This is its HTTP interface, which is my card service here. And now let's try if it can reach the database. So here I have a method called card get items table card. And indeed, it's now able to connect to that RDS database through this VPC Lattice TCP connectivity. Now you have to trust me that I didn't fake this. This is actually coming from the RDS database.
So Yves, just to really help it sink in, what's the primary advantage of inserting VPC Lattice here for the RDS access, as opposed to what customers would be doing today?
I mean, today, what you would have to do is you would have to use a transit gateway or VPC peering to share the database. And usually, so a transit gateway or VPC peering is like blank connectivity. It's any to any, you can access anything. So the next step that you then usually do is to put a firewall in between to block everything, and then to just allow specific TCP ports. And with VPC Lattice, we have kind of the opposite model. We only connect what we configure into the service network. So there is no any-to-any connectivity between those accounts. It's really a target connectivity of saying, I want to expose that RDS database to that specific service network. And then on the service network, what I'm not showing in this demo here, I can also apply policies saying the request can only come from this VPC ID. So I can have basically a more fine granular authentication and authorization for those TCP services only for that connection to that database. Right?
So to add to what Yves is saying, like, think of it as two big buckets. One is connectivity. So before this was available, you would have to somehow connect the two accounts together, whether it's transit gateway, peering, or maybe even private link, right? There, you had some limitations. If you were peering on transit gateway, you had to make sure there are no overlapping IPs, etc. And then you had to make sure IPv4, IPv6 mixing and matching. So those go away now with this way of sort of connecting. You could have, EKS running on IPv4, your RDS could be IPv6, vice versa. And then second, you could have across accounts. And like Yves was saying, the second big bucket is access control. So before, with layer 3 connectivity or peering, anything could flow, and you have to use other mechanisms to sort of do security groups, et cetera, to do access control. Now you have this by invitation only. So the provider side, like the RDS side, will only extend the resource only to the accounts that need to connect to it. And then you control that by who participates in that service network, like Yves was saying. And then on top of that, you can also control access at the resource level, which is, we plan to add that support very soon coming up.
Okay. Yeah, I see that Ryan kept me honest here that the resource level aus policy is not there yet. So I was referring to, first of all, service level policies,
right,
and also to TLS pass-through policies where we can match on VPC ID. Is that right, Ryan? Before you have to correct me on the chat again.
Yes, it's correct. It's on our roadmap, but if someone goes looking for it today, they won't find it.
Okay.
I'm glad we have Ryan here, keeping us honest. All right, guys, we've got a few questions in chat here. So, Yves, before we jump to those, anything else you wanted to demo or show us today?
Oh yeah, last thing for the last like 3 minutes, let me show you the Vitess one, because that is using DNS as a method of connecting. So here what I have in the resource configuration is a DNS-based one. And you simply say in this resource configuration, resolve the domain name mysqlvitess.org. Now, where is that coming from? What is that? Let me go to the console again. And here we have a cluster which is called Vitess cluster. And that's actually in the provider account. So in the on the light green side, here we go. And Vitess is a cloud-native database system on Kubernetes, and it has what is called VT gates. VT gates are pods that are exposing a TCP 3306 interface, a MySQL interface to the databases running also in pods. And what I did here is I created a headless service, again talking about this overloaded term of a Kubernetes service. And that headless service is connecting the IP addresses of the pods that are serving the database here, or the port 3306. And then I'm using external DNS controller to populate Route 53 with this DNS name. And so if we go back here to DNS, then we see we have a mysqlvitess.org, which has those two pods that are the VT gates, right? And this resource configuration is pointing to that name. So now our resource gateway is calling DNS Route 53. And right now it has to be public DNS, but it can return private IP addresses. It then returns the IP addresses of those VT gates, and then we can connect to our cloud-native database through DNS running on the Kubernetes cluster. And so we can check it here. Again, you need to trust me. It really comes from a database. It's the other pods, connects to the database, and here's the response coming from Vitess.
Yves, I'm really glad I asked you if you had anything else to show us, because this is exactly what the next question was. We had a question in chat from Serhi asking, what if they had, self-hosted MySQL, Redis, Elasticsearch, and a question from Morali as well of, can you support resources that are not supported by AWS Resource Access Manager, like Kubernetes resources, DNS, that kind of thing. So I think there's your answer, folks. If it exposes kind of like a layer 4 endpoint like MySQL and like the 3306 port, then you can expose it. Now, do you have to use external DNS for these types of services, Yves?
No, it's just an example of me using external DNS to deploy the database on Kubernetes and to keep it cloud native in a way that I can add and remove those VT gates pods without having to configure or reconfigure anything, right?
Got it.
You don't have to use external DNS. You could also use basically static IP addresses. But then every time you change the service that you use, then yeah, you have to update your resource configs.
Yeah, the key to note here is those are headless services, right? So you're not putting in a load balancer in front of it. So it simplifies a lot of that deployment from a customer side of point of view, debugging, troubleshooting, latency, etc.
Yeah. So the resource gateway is actually directly talking to the pod IPs. And that's because we are using the VPC CNI in this cluster. And so the pod have reachable IP addresses in the VPC. And so it's not going through kubeproxy first to reach the VT gates.
Got it. That makes a lot of sense. And so, I folks in the chat, if you have any more questions, please take advantage of us having the experts here. We're kind of coming up on time here. Eve, I want to ask you anything else that you wanted to demo or show. I think we've spent the majority of this episode going through this hands-on demo, so this has just been awesome. Thank you.
No, I'm at the thank you slide.
Perfect. Okay, couple more questions coming in here. What if we have those self-hosted entities in standalone EC2?
Yes, that is supported too. You could expose that as a DNS resource in the resource gateway, and then your EKS service that you showed on the other account can just use the DNS name, and you can also do a custom domain name for that. And the resource gateway will route it to that standalone EC2.
And I think naturally you can extend that to, well, what if it was running on Lambda? What if it was running on my own data center? What if it was running somewhere else? Well, maybe not own data center, right? Or could it in this situation?
We do that too, yeah. Like, for example, let's say your EC2 instance is running in outposts on your data center, right? And the resource gateway over DX or VPN can route it as long as the route's there to go to that on-prem IP resource. So in Lattice, what we do is a DNS lookup. We get the IP address of your on-prem, wherever that resource might be. And then resource gateway, through the VPC routing that's normally set up, can route it over whatever the connectivity mechanism you have to get to the on-prem. So you can have it in both directions. You can have something on-prem can also call a resource in AWS as well. It works in both directions.
Got it. And that very first demo that we saw though from Eve showing the service import, service export, is that limited to just VPC on AWS cloud, like resources running in a VPC, like whether it's Lambda or EC2 or Kubernetes or whatever, or does that also apply to like outpost-based instances and potentially other areas as well?
Today, it's limited to within AWS VPCs. So the service import export specifically to EKS, right, or self-managed Kubernetes, and then in the controller we don't support like Lambdas, etc. today to do that service import export today. But if that's an ask, we can look at it. Those will be going beyond the gateway API specs, sort of adding annotations and CRDs to define native AWS resources like Lambda, right? But with another thing that you should be aware of is the EKS hybrid nodes, where you could have a potential EKS service, the subnet that is specified on an outpost subnet with IP targets, and you could have an ALB with targets that are pointing to the subnet that is in outpost. So with Lattice, the same techniques will apply. Like as long as the VPC knows how to route it to the outpost subnet, we should be able to support that through hybrid nodes, which is what is a big change for EKS as well, being able to have a single control plane, to have multiple nodes that are running on-prem, be part of the same cluster, and you could have it fronted by an ALB that's running in AWS to expose it to the internet, etc.
Yeah, you guys really do think of everything. Of course, hybrid nodes being this new feature we announced at reInvent, allowing customers to bring up nodes in their own data centers and connect them to an EKS cluster. And of course, earlier, Eve, you mentioned that the demo that you were doing was running on auto mode clusters. Another announcement that EKS had recently at reInvent, helping customers manage their worker nodes, manage their various add-ons in their clusters, load balancers, that kind of thing, helping reduce that overall operational overhead. Now, a couple more questions here, guys. So in the case of network policies that are applied in Kubernetes, how does this work with VPC Lattice? And kind of the similar question from Serhi, when you have network policies applied on your cluster, how does that work with VPC Lattice?
So network policies, you will have to allow ingress from the VPC Lattice IP addresses. So there are two IP address or IP blocks or IP CIDRs that VPC Lattice is coming from when it talks to the pods. And if you use network policy alongside VPC Lattice, when you define your namespace policy, you will have to allow the access in from those two CIDRs. And we're publishing those in a prefix list. Now, in the case of network policy, you would have to basically just read that prefix list and take those two CIDRs. But they are not expected to change drastically. One is one out of the 169.254 link local range, and the other one is a public IP range of Amazon. Got it.
One last question here. I think it's our last, unless folks have more. From Morali, any considerations on cluster version compatibility? And Brian, I'll point this at you, but I'm guessing it's just if the gateway API controller is supported on that version of EKS, should be good, right?
Yes, exactly. We haven't run into any versioning incompatibilities recently. I do my best to keep things up to date. So if we were to find something that was incompatible, we would address it pretty quickly. But as of right now, no, I'm not aware of anything.
All right, awesome. Good to know. Okay, guys, as we finish up our episode today, I just want to go around the room and say anything else you want to share with folks, any resources, how they can get involved with the community. I know AWS works closely with the open source community in this regard with the Gateway API. Anything you want to share? And Satish, I'll start with you.
Great. Yeah, a couple of things. I think sorry if you haven't shared the links already, that those are the Gateway API controller is open source, and that is 1.1 release is available on GitHub today. And I encourage you highly to sort of look at the code, participate, help us build it, give us feedback. Happy to keep building on top of that. And then from a other resources point of view, think of it as you're not just for EKS, but also for your self-managed Kubernetes on AWS as well. Right. So again, this is about compatibility, extensibility, and keeping in pace with the goals of the Kubernetes community. And then second, in terms of the specific use cases, we haven't even gotten to those topics yet, but happy to come back on and discuss more of the use cases. But lots of multi-cluster, not just EKS, coexisting with Istio, other service meshes, extending your Kubernetes environment to speak to other compute types, ECS, Lambda, Fargate, serverless compute options, etc. Those are where we're seeing, the Lattice plus EKS being very powerful.
Awesome. Thank you, Satish. And did drop a few of those links in the chat here. Eve, Brian, anything else to add?
I'll probably just echo what Satish says, and happy to have anybody hop into the controller repo there and start a discussion or talk through what they're thinking. But yeah, you can find me there.
Cool. Awesome. Eve?
I just say go play, go and try it out, and yeah, connect to us over all means if we can help with something.
Awesome. Thank you again, guys. And I'll use that as a segue to plug EKS Workshop, where we have a module focusing on on VPC Lattice, working on EKS, as well as the relatively new EKS Security Workshop, which also has a module about service access with VPC Lattice. These are great ways to get hands-on, but also reach out to your AWS account representative and ask them, hey, give us a demo, give us a workshop on VPC Lattice. I think it's the best way to get you and your team, your leaders, hands-on with some of this cool new tech. Again, folks, thank you so much for joining us wherever you are joining from, catching another episode of Containers from the Couch. Be sure to subscribe to see more episodes like this in the future. We've been doing live episodes every Thursday for over the last month, so you definitely don't want to miss it. Again, to our guests, our AWS experts, Satish, Eve, Ryan, thank you so much for joining us today, for the awesome demos, for
My pleasure.
awesome coverage on VPC Lattice, and for our viewers back home. Catch you next time.
Thank you all.
Bye, everyone.